Hello everyone, welcome back. In this video, I'm going to introduce you to Augmented Reality, AR. Augmented Reality is a technology that overlays digital information such as images, text, or 3D models onto the real world, enhancing the user's perception of reality. Look at this. This is it can be the picture, it can be the sculpture, it can be the statue, and this guy is wearing a certain glass. But what's that glass? Sort of camera, kind of enhanced vision. If you have a simple camera, you can do it too, as we'll see it in a few minutes. Look at this. This is a mountain gorilla, and the guy is looking at the mountain gorilla. And apart from looking at the mountain gorilla, there's a layer of details popping out, or you can choose the display. It's up to the designer to choose the display. And same here. This is a sculpture. And this guy here, he's looking at the sculpture or a statue, and there's a layer of information popping out to help the observer or the user understand more about this object. Can we use augmented reality with OpenCV? Or can we program augmented reality with OpenCV? Yes. Let's start with Aruco markers. Aruco markers are visual codes used for object tracking and pose estimation in computer vision and AR. What's pose estimation? Because I expect you understand object tracking. If you watched the previous videos that I made, you understand what object tracking is. But I don't know if you understand pose estimation, what pose estimation is. So pose estimation is the process of determining an object position, X, Y, Z, and orientation, roll, pitch, yaw, in a 3D space relative to the camera. I didn't make a video about roll, pitch, yaw yet, but I'll do it in the near future. Well, we'll be exploring gyroscope sensor. In Aruco markers, pose estimation helps identify the marker's exact location and rotation, allowing augmented reality systems to overlay virtual objects accurately. So let's have some fun coding basic augmented reality. But before we start coding, I would like to tell you to relax, because every code that we're using today is uploaded here. You can always visit my GitHub account and you will find everything there. Okay, so we have this code. I have this image, selfie.jpg. This is the image I am talking about. Selfie.jpg. And I have this code to detect Aruco. Here is the code to detect Aruco. The code is simple. As you can see, I didn't use any strange library that I don't know. I tried to use NP, but NumPy, but NumPy is not even needed here. I can remove NumPy. So I don't have a new library that you don't know. I have CV2. I have time. This is native. You don't have to install time most of the times. And you have everything you want to set. So what we're going to do is we look into the dictionary of Aruco markers. Actually, OpenCV has a dictionary of Aruco markers. So we have a number of Aruco markers. I think I have them here. We have 250. Yeah, we have 250 Aruco markers. 50, yeah. Or 240. Okay. Aruco markers. So you can choose one Aruco marker and use it. What does Aruco marker do? As it's set in this code, we print an Aruco marker and we put it or we place it on the object we want to get more information about. You will see the demo shortly. So, what are we doing today? This code will just read this picture. When you detect Aruco marker that 3, Aruco marker that 3, Aruco marker that 3, it's here. If marker ID that 3 is found, then you display the selfie. That's the summary of this code. If you detect the Aruco marker ID 3, just display a selfie, that selfie picture. So how does Aruco marker number 3 looks like? If you look at these Aruco markers here, okay, this is Aruco marker number 3, and this is how it looks like. So in our code, we said wherever we find this code with the camera, okay, there is the camera is inputting the video to the code, and the code is analyzing if there is in the view, if there is a marker, an Aruco marker 3, and when it finds it, it will display selfie. This is how the code works. Simple, right? Okay, so I have printed this Aruco marker, and let me show you the Aruco that I printed. So this is the Aruco. You can see its size. You can compare. This is the size of Aruco. Small, right? So I placed it on the table, and I will be running the code and will be trying to see if when the Aruco is detected, we can be able to display the image. Selfie. Okay, so let's run in the code. Okay, the camera started. I'm using the phone that I saw earlier. So I am trying to look for the Aruco, expecting that when when I detect the Aruco selfie picture is displayed. You can see I am here. I am here looking for Aruco. I am looking for Aruco. Where is Aruco? Aruco on my table. You can see it. When it comes into good view, then selfie picture is displayed. Does it look like magic? We have this the Aruco as simple as this. We have this basic Aruco, and when we detected it, we, instead of displaying the Aruco, we displayed the image. We can display a text. We can display a video. We can display it in the way we want. It will depend on how we want to design it. As long as the camera detects an Aruco, you get what you programmed. You display what you programmed. It means in the museum, you can visit objects, but whenever you point your camera on the object, you get a layer of information, another area of information that you cannot see with your eye. And the way you present it, it will depend on you. Okay, I expect this was good introduction to augmented reality. It was just using an Aruco to add another information. So, for example, if this Aruco was on the simple object, that would be a good way to show this is selfie. So be creative and do something fun and meaningful. Thank you. Until the next video, bye now.